All right, here's the my bearings. These are the two angular contact bearings that are going to go in the front of the spindle, and here's the one that's going to go in the rear. It's just a regular ball bearing, a precision ball bearing, that is. So I need to know the exact dimensions of these bearings. I know they specified this should be a 35 millimeter bore, and these should be 40 millimeter bores on these angular contact bearings. But first we're going to check the smaller one. Now I've set up a stack of gauge blocks. I don't know if you can read that on there, but they're I set up this as close as I can on inches. I don't have metric gauge blocks, unfortunately, and the 35 millimeters is 1.3779 inches. So I've got a 900 thousandths, a quarter inch, a 127, and a .1009 gauge block. And this equals the 35 millimeters to a 10,000th of an inch. It's actually a little bit bigger than that. These are the actual numbers right here. I'm not going to worry about these. I can't even machine something that close probably, so this is probably as close as I'm going to get. But what I want to do is be able to measure this bearing and know exactly what size the bearing is, and my micrometer that I'm going to measure my shaft with, what size it's measuring. So I've set this up. And the only way I can do this with what I have here is with this dial bore gauge. I don't really have a better way at the machine. Let's see if I can make this so you could see it. I've got these gauge blocks set up to set this dial bore gauge. And what I got to do is zero that. I don't know if you can see that very good. There's a lot of reflection here. The light's not very good in this part of the shop, but I've got that zeroed on my gauge block stack. I'm going to stick my bearing in here and see what size the actual bore of the bearing is. According to this, the bearing's probably about 2/10,000ths of an inch, according to my dial bore gauge, smaller in diameter than 30 millimeters. Let's check it on another spot, rotate it around. I don't know if you can see this all here. Just trying to get this so you could actually see the dial bore gauge's dial indicator, and but I'm holding the bearing over here, and I'm trying to actually hold the bore gauge the same way I held it when I set the zero too, just to see if I can get this measurement as accurately as possible. So I'm getting about the same thing. The bore of this, just out of curiosity, the bore of this bearing is quite a bit rougher than the surface on this gauge here. I can feel it on the dial bore gauge. In fact, this is one way you can actually feel the finishes of bores, because you can actually feel it when you run your dial bore gauge, back and forth in the bore. When you're machining parts on the machine too. So I'm getting about 2/10 of a thousandth smaller than the actual nominal size that I could measure here. Now let me check my my micrometer here. I want to make sure that my mic is actually reading the actual dimension of this stack of gauge blocks. So here's my 30 millimeter stack, and my micrometer. The light's not very good here, but so I don't know if you can see that or not. It looks like it's reading pretty much exactly where it should on the micrometer. It's like right on the exact size of these stack. So I need to know all this stuff when I machine the shaft, because I want to make these bearings fit as close as possible on the shaft. Now on the Mazak, I should say this, there isn't any way to polish anything as far as in the machine, because you cannot run the spindles, either the milling or the turning spindle, with the doors open, so you can't really polish anything. So I have to attempt to get this as close as possible on the machine, and then I'm going to possibly have to take this thing over to the engine lathe and polish it. So the 35 millimeters, I'm just going to write this down. Bore actually measured 1.377, and it was 2/10 thousandths, so 7 is the actual dimension that I checked with my dial bore gauge as best I can do it. So, and the micrometer's reading dead nut on that dimension, so it should be, if I machine this shaft maybe a few tenths less than that 1.377, let's say 1.375, that bearing should just barely slide on there. We'll see if I can hit that dimension on the machine. So let me set up the stack of gauge blocks to check the 40 millimeter diameter of these angular contact bearings, and we'll measure them the same way. Gauge blocks, the way I do this, I know my dimension here is going to be a 1.5748. So the first thing I'm going to do is take my smallest dimension, which is this 0.1008 gauge block. I'm going to set that aside here, and then I'm going to start subtracting off things here to get to my final dimensions. So so the easiest way to do this is just to actually take the number 1.5748 and subtract the first gauge block, and we got 1.474. So if we subtract a 1-inch gauge block, that's going to be this gauge block. Set that over here. We got 474 thousandths. If we subtract, there's a gauge block here that's a 450. Let's see if that works out. Minus 0.450 equals, okay, that leaves 24 thousandths plus 0.450. I should have taken 350. You got to think, you don't have any gauge blocks except for the 50 thousandths one here, which you can use, but you don't want to stack too many of these things up, so you got to start thinking in 100 thousandths in the case of 1-inch inch gauge blocks. So minus 0.350 would be a better selection here, and that leaves 124. So if I take 350 and the 124 thousandths gauge block, those are the ones that I need to do this setup. So let's move this out of the way, and let's ring all these together. So the 1-inch and the 1/4-inch one, and I kind of ring these together thickest to the thinnest. It doesn't really matter, but and like I say, this is my most accurate way I can think of to measure this right here out at the machine without going into inspection and using some kind of height gauge and all that stuff. So I'm just doing it this way here, so I have an idea of what I'm doing. So let's see if the micrometer, first of all, if we have the right size set up, which is Okay, we're looking at 1.5748. You probably can't read that because of the reflection, but it's reading pretty much dead nut on this micrometer as far as reading the veneer and everything on here. So that looks pretty good. So we're going to stick our end pieces on here and set up a dial bore gauge, check our bearings. Going to ring the end pieces on here. This hardware, by the way, comes from I'm going to show you the set here in a second, as soon as I screw this together. Kind of important to have this held together when you're setting a dial bore gauge, because even though they don't have a lot of spring force on them, it'll separate the blocks. This set of stuff comes out of this Mitutoyo set right here. There's the numbers if you can read them. And they have various things in here. These end pieces, the screws to hold things together. There's even a base if you're going to set up like a height gauge and it's kind of like a scribe thing if you're going to do that kind of stuff. There's different end pieces. Here's a thing to go to this in the center of a hole. I rarely ever use these two things here. Mostly I use these end pieces and set, up gauges to set my dial bore gauges on. But that's what this set is. So with a square set of gauge blocks like this, this set, this is kind of a cheapy. I've had this set forever, and it's just a little, it's kind of a shop set. It's not really a inspection grade. It's a grade B set, but these are plenty accurate for around the shop, and I've had this for years, and I've been using these, and they've always been accurate enough for what I do. Now I got to go get my appropriate dial bore gauge for this length, because this one's is out of its range here. So let me go get that and the proper setup for that. All right, here I've got you saw me set up the gauge blocks. I got a 1 inch, a 350 thousandths, 124 thousandths, and a .1008 thousandths gauge block set up. That's our 40 millimeters, as close as we can set it up with an inch set of gauge blocks. I mean, it's not exact, but it's well within the machining tolerances we're going to deal with here. Now, I set up this dial bore gauge here to 0 on my gauge block set. I could do it here for the. Okay, you can see it's set at 0. A little awkward to do it this way because this isn't the normal way I do it, but you can see that's on 0. So that's our gauge block set, our reference, I guess you might call it. And now let's see what our bearings check here. I'll put it in the bore of the first bearing. And these bearings are pretty much dead on 40 millimeters. This one is, the first one is. Anyway, see. Well, let me check it all the way up and down the bore. Maybe not. It's kind of awkward for me to do it this way because I'm trying to make it so you can actually see the gauge. So normally I wouldn't do it this way, but the light here maybe that's a little bit smaller actually, now that I'm looking at it. It's about almost 2/10 smaller like the other one checked. Maybe 1.5 ten-thousandths smaller, that particular bearing. We're going to call that maybe 1/10 of a thousandth smaller. get this, let's check it in another spot here. 1.5 10,000ths smaller. Okay, on that bearing, let's check this other one. I probably could actually heat up the bearings and slide them on the shaft if it was right at 40 millimeters. Maybe that's the way this is designed to work. I don't know. But actually I want, that's about 2/10. I don't know if you can see that gauge. I'm trying to get the light. Maybe there, that'd be better. It's about the same size, 1.5 10,000ths. Let me rotate the bearing a little bit here. Try it at another spot. Pretty much the same. So both these bearings are pretty much the same size, 1.5 10,000ths of an inch. They have their, let's see here, there's marks on the bearing. I don't know if you can see those. They're very, even hard for me to see them here. But basically, we're going to face the markings on the inner race outward to get our, and set our spacers between the bearings to get our preload. And initially, I'm going to make both the spacers the same length and see how that works. And if I have to, then I'll shorten the middle spacer a little bit. I have to go over the surface grinder and kind of kiss them off. I don't know if you can see that mark. Here's one of the V's on the OD of the bearing. I guess it would be good to try to line them up too, if you really want concentricity. Here, there's the other one. I don't know if you can see that. You might not. Well, they're hard for me to even see just looking here, but they're facing outward this way. And I've already checked this to kind of verify it, that if I push down the race this way, it spins, and this binds up. So this has got to be the open side of the outer race, if you will, on the riding side. So I got to face the markings outward on that. So the actual size of our 40 millimeters, if as best I can measure it, bore is 1.574, and let's say about 1.5 10,000ths below that, just to make sure I get this right. 1.5748 minus 0.00015. 1.57465. Now, I'm going to shoot for something a little less than this, maybe, 1 to 2 10,000 smaller, so the bearing will slide on there without having to press it or heat it or something, because I want to be able to adjust the preload with the nut on the shaft here and everything, which you'll see in a sec, when I get to that point. I wanted to check all this before I started the machining. Now I've got the setup made over here at the machine, and we can go over there and look at that. It was kind of a tricky setup. It doesn't sound too complicated really, but it's a little bit tricky because you have to get the shaft and everything running as true as possible the way I'm doing it here. Well, let's go over there and look, just so I can kind of explain what's going on here. I put the this ITS extension in the chuck And I had to get that running as true as possible because I want to get the, I've made 2 of these just in case. I want to get the bore and everything where the tool mounts as concentric as possible, and I'm actually mounting that on there like that. And then I had to, without the tailstock in here, I had to skim this center with a tiny boring bar so that it ran true when this was clamped onto the the tool holder and everything like this. So I get, hopefully that'll have my spindle taper running as true as possible. So this was a little bit tricky. It doesn't sound that tricky, but even the when the spindle would break to a stop here, this thing has like gears in the head and everything, this big lathe, and it kind of clunks a little bit, and that would be enough to knock it out of whack way out here when it wasn't supported with anything. And I had to kind of ramp the spindle down and up and down slowly. I did this manually. I just manually jogged the machine to skim these centers, and it was a little bit tricky because I tried to get this running as true as possible within 1/10 of a thousandth out here on everything, and I wanted to get this center without any support from the tailstock when I indicated it to run true as close as possible, so when I machine this whole shaft for the bearings and everything, it will run true, or the spindle bore that I've already machined will run as true as possible to this thing. And I think I've sort of accomplished that. These little centers, I had to, I carefully bored them, the chamfer, the 30-degree chamfer in these centers to run as true as possible. And this is best as I can do. And now I'm going to machine the shaft for my program that I've made. And I'll explain that as I go when I get to that point. So anyway, checked the bearings, wrote down the dimensions I'm going for, checked the micrometer, made sure everything was good there. Now we can go and start machining the shaft. All right, let's go over the machining plan a little bit here. We're looking at the part. Let me turn on the part solid so you can see it here. This is the program I've made to machine the shaft in Esprit. I'm going to turn off the solid because we can see the simulated cuts better. So here's just I'm going to rough the whole OD. I'll show you the simulation in a second, but here's just the processes. I'm going to rough the whole OD down in one cut, or one roughing cycle, I should say, and then we're going to do a finish cut this much on the end of the part here, because the first bearing mounts right on this 35 millimeter diameter on the end of the shaft, and then we're gonna go to a program stop over here, and we can run that over and over again till we get that to size. And then I'm going to set the offset back out on the finishing tool, and then we're going to run this part because the 2 angular contact bearings set on this diameter, the 40 millimeter diameter here. And that way I can run them separately if I have 2 different diameters. I don't really want to run a finish cut all the way down the length of this part, because I want to be able to adjust the diameters at each set of bearings. The end here for the 1 bearing, and the middle here for the 2 angular contact bearings. And then we're going to run a thread. This is a 30 millimeter by 1.5 millimeter lead thread here that fits my nut I've made, and then the thread up here that adjusts the preload on the angular contact bearings, and this is a 40 millimeter by 1.5 millimeter lead thread as well. And then we're going to cut a keyway for the lock washer, or the retaining washer for the nut there, and then a keyway here for this retaining washer. So let's look at the simulation of all of that. Here's the machining simulation of everything. So this is a roughing cycle, roughing all the way down the whole shaft, because I'm just going to leave, actually I'm going to set that big and leave a lot of stock, so I've got a lot to work with on my finish cuts to get the size and the finish good the way I want it. And then we come in with the first finishing pass, just the end of the shaft. That end it just went by is where the bearing fits on, and this middle area here is just clearance. Doesn't have to be precise there. And then the second cut, this diameter fits the other bearings, so it has to be precise. And then it goes up to the end here. The other end of the shaft, of course, is already machined, as you already saw in the video. And then we cut the threads. On both ends, the end and the middle here for the two nuts. And then we come in and machine the keyways for the, I don't know, the star, the tabbed lock washers, whatever you call those things. So that's the plan to do the machining of the shaft. And as I said, I want to take two different finish cuts along here so I can adjust each one of them separately to size for the bearings. I don't really want to take a chance of cutting a finish cut all the way down the length and then have one area not the size I want. So that's the plan. Pretty simple, actually, but just thought I'd show you that before we get to the actual machine work here. All right, I think we've got something here finally. I had to polish this diameter a little bit on the lathe, on the engine lathe over there, to get the bearing to go on the way I wanted. The actual diameter measured here, I think I made this about a few tenths bigger than I wanted on the lathe. Now it's at we said that 1.3777 was the actual diameter of the bore, and 1.3775. So we're about 2/10 of a thousandth under that dimension here. And down here, I was able to turn this on the lathe, and we're actually let me see. We're about a thousandth and a half. I mean, a 1.5 ten-thousandths under this size that we measured here on this. Maybe a little bit more. Maybe 1.6 ten-thousandths, I think, under that size that we measured. So let's see how things go here. This is one of the angular contact bearings. You have to get these things started just straight or they're not going to go on. Okay. I mean, that's a extremely close fit there. And then these spacers would go on. These aren't ground to the right thickness, so they're not going to preload right at the moment. And then this bearing would go on. Like that. And there's the keyway's machined in here to mate to this. But this particular lock washer thingamajig, you have to, it just barely fits over the shaft against the key tab here on it until you get it down in the keyway of the, then you could get it down on the diameter. Then this, the nut, I marked one side that's away from the bearings because this side was machined and threaded all in one operation, so it would be perpendicular to the thread as best it can. And that goes down against there like that. And then this bearing would go on, which would be the tail end of the spindle cartridge. This stuff has to be started perfectly straight. It's kind of hard to get over these threads. Probably should have machined the thread OD just a hair undersized. And then this washer goes on like this in the key, and then this nut, and everything would tighten up, and you would of course bend the appropriate tab over. Once you get this thing tightened, whatever tab lines up with the wrench thing. Now these won't preload right at the moment because they're not ground the right lengths, but anyway, that's the assembly as it's going to go together when it's put in. This being smaller in diameter, it can be inserted all in this direction. Actually, that I'm leaving off one part here. There's a nut. There's actually a nut with an OD thread on it that goes there. So actually I should be assembling this thing when I finally put it together for real. I'd be putting this nut down here against the, because this is the nut that holds the whole thing into the spindle. So I guess I should check that too. So let's take this all apart. We'll go here, like this. That bearing off. These spacers. That. Now this would go in here like this. Like I say, that nut is going to thread in there and push on the outer race of one of these bearings to hold it all in the housing, like this. Now I have to also bore out this belt sheave that's going to go on here. It's going to be a fit on here, probably with Loctite to hold it on. And maybe I'll put a pin in there too. I haven't decided on that, but I think the Loctite might be fine because this isn't going to be under real heavy loads. So that threaded piece is going to hold the whole thing in the housing. These two spacers will go on here like this. This will go on here like this. Why did you get it on there straight? Wow. This is kind of hard to start on that thread. Lock washer thing, tab washer, whatever you call these things. And there, nut, the appropriate side down, like that. Tail end bearing here, which is just a precision ball bearing. It can float in the bore, and then this thing goes on here like that. So that would be the finished assembly like this. And this all is going to slide into the housing, and this is going to hold it. This threaded nut thing is going to hold it in there. And this will be up against a shoulder inside the housing. This all slides in a close fitting bore on this bearing, so the whole thing can be inserted into the housing and threaded in there with this. Now this is going to be a little tricky because that sheave is going to be right on the front here, and it's going to be permanently attached to this to the spindle. So this will be kind of captured between, and the wrench is going to have to be thin enough to get between here to tighten this up. And there's also a little seal on the way cover, or belt guard, I guess you call it. It's kind of like a wiper seal that goes through here. It goes in there like that, and that's going to go over and cover the sheave and the belt up and everything, and we'll still be able to get to the mount and unmount tools through this hole here, like you saw earlier in the video. So that's the whole assembly. And hopefully I did good, and I get my run out low enough here to make this work properly. I've got to surface grind these spacers still, of course. So a lot of parts going together here, and some of them have to fit pretty darn close. Bearing. Nut. Spacers. So on. So that's about it for this video. The video was mainly about this spindle shaft. All these other parts were actually made at Centerline in their shop. As far as the well, these were purchased, the bearings and these lock washer deals. But the three nuts and these spacers were made by Centerline in their shop. I didn't have time to do it on my machine, and I was just making this spindle, put everything together, because this has to be done pretty precisely. So if you have any questions, put them in the comments. Thanks for watching.